Yep, we went live. Can you check if it works?
Alright, just a sec.
It says excellent
Yep.
connection. It should work.
Live and well.
When we switched to English, you became much quieter.
Oh yeah. Well, it's general shyness of giant auditory of 2 people. I think. Oh, okay, it's us. No worries.
Okay, today we are here to talk about reproducible development environments with Andrew Zhurov from United Kingdom.
Hi everybody, that's my mic setup, so a bit awkward, but let's get just started. Thanks.
Okay, let's start. Small introduction. We will think about hypothetical project, which is web application consists of few different parts, and some of them written, for example, in Python, some of them in Clojure or Java or something else. And Python code will be also a little platform dependent. It will be using, for example, CUDA and interact with NVIDIA GPU. And we will try to understand how to make a development environment in such a way that it will be easy to move this environment from, for example, your laptop to the desktop, or to just synchronize two development environments of different developers which works on the same project, or for example, when new developer come in your team, you want him to get set up and get started pretty quickly. And also we want it to be as close to production environment as possible. Yep, it will be our use case for today. And let's talk about parts of development environment. First part will be operating system and system related parts like kernel or drivers. It will be important for our ML part of the project because we will be using drivers for NVIDIA GPU, for example, and it should be installed somehow. And in most setups, development setups, it will be installed differently for different developers. Some of them will be installing it using some system package manager. Some of them will be installing it from binaries from some site, and so on. And it's already a place where your development environment can be reproduced correctly. And we will find how to bypass it. Another thing of development environment is actually your tools, like browser for web applications, when you have DevTools or IDE or your text editor or something similar, or tool for managing your cluster and so on. And another part of development environment is package managers, and it can be a lot of different types. Your language related package manager, for example, for Java it will be npm or yarn. For Java it will be Maven or Gradle or something like that. And services. In many projects you need some kind of service, for example, database or queue or cache or something like that. And it can be set up and running on your system using your init system or using Docker or some other similar tools. You also have project dependencies, which can be installed in your system or can be installed using your language package manager, or can be include in your project by Git submodel or in any other way. And we will find the good balance and good way to include those dependencies in your project, making your project more reproducible. And obviously it's other different tools which are project related but don't contribute in your end product. It's building tools or cluster management tools or some plugins for IDE which can be distributed with your project too, or at least some instructions how to get them, or some scripts or configurations. And obviously project configurations and environments, for example, your database URL, which will say to your application how to connect to database and some other stuff. And let's discuss what we want to get from our environment, development environment, which characteristic it will have. It should be declarative as possible, and it's very important because if you say someone how to set up his development environment in imperative way, like you will provide an instruction which have 12 steps, and each step describes some action, and some other developer will introduce another dependency in your project or another tool in your project, and he will insert another step in this instruction. It will be very hard for all other developers to run this step, because if the step in the middle of this instruction, they will need to remove the whole environment, or they can get a different result, because you can't just switch steps in order in many cases. For example, you can't compile before you installed your compiler, and so on. That is why it will be good if you have some configuration file or something similar which says how your environment looks, and you have one command which instantiate this environment from this configuration file. It will be pretty cool and very useful, and also it will contribute to reproducibility of your development environment.
Oh, could I ask a question?
Yep.
So we have such a tool, for example, Ansible. We use Ansible in production, so we could just take it and be happy, right?
Yeah, it's pretty good question. Actually, Ansible is exactly what you want from declarative tool, where you have a definition of what you want, and you can just say set up the environment in this way and provide this definition. But the problem in implementation of this tool, Ansible doing everything imperatively. Actually, it's very complicated bash script in very raw details, which try to understand how to move your environment from current state to desired state. And for example, if you remove some package from your setup and from the definition of your environment, Ansible not always can say if it needs to run apt-get, apt-remove or something like that to remove this package, because this package can be used by different part of your system. And also Ansible modifies your system in place, and it can break another project, which also not very good, and also it breaks reliability of our system, of our environment, and it's pretty bad. The second, I hope I answered your question.
Yeah, you've got a nice point that it will modify my system and will break my globally installed tools. That's not cool.
Yeah.
Thanks.
Another thing that at least I want from development environment to be isolated from your operating system. Hi, Gleb. Thank you.
I'd love that too. Yes, please.
It should be isolated because you don't if you want to work on two different projects, they can conflict. For example, one project uses Python 2 and another project using Python 3 and Python 3, and you can't install both Pythons in the same directory because it will be conflict of the clash of names, and you can get a lot of problems in similar way. That is why every development environment should be or even must be isolated from your operating system in the way that it doesn't break any other parts of the system. And the same works in opposite direction. When you modify your system, install other applications, for example, you install Docker Compose in your system, and it shouldn't modify your Python version of your development project. And reliability, it's good property because if you break something, you always can roll back commit in your repository and get previous version of your development environment, and your tool should be able to support this feature. For example, in Ansible, it's not always possible. But
I love that so much. One time I've been trying to wrestle the NVIDIA driver 2 days straight, and I ended up reinstalling my whole operating system over and over again. And it's like 10th try. Oh, actually, I just let it go. I lost this war. I didn't install it in the end, actually.
Yeah.
So yeah, reliability. I love to just roll back.
It's a curse of many modern operating systems, which not so modern in terms of internals, that if you broke something, you can't easily roll back without using features of your underlying, for example, of file system that can snapshot items. Yeah, and that's very cool property to have. We have few easy solutions, obviously. You can use one development machine for many developers in your team. Just put a lot of hardware and a lot of memory and so on, and install all necessary dependencies and make everyone work on this machine without modifying it too much, without installing additional dependencies. And everything will be centralized, but for example, it will be hard to run tests on the same database. You will need to create new databases or something like that, and you will probably start conflicting with other developers trying to get some resources from the system.
Yes, it's like one sandbox and two kids playing.
Yes,
you will end up stealing each other toys.
it can work in some cases. For example, when you're doing analytics of some database and you need only read-only access, but in more general case, it won't work probably. That is why we go to the next idea. We can froze the operating system in some image and distribute this image among our team members. For example, you can create an ISO image of your operating system with all necessary dependencies and all source code and so on, and just give a disk with ISO image burned on it to the developer and to ask him install it. The problem is obvious that he won't be able to use his favorite IDE or browser or his configurations on such system, because it will contain only dependencies necessary for the development. Also, if someone will decide to introduce some new dependencies to the project, you will need to make another image of your system. But if we look deeper in what is happening right now, many people using Docker images, which is basically the frozen image of operating system, but it runs not as your primary operating system, but like a secondary or Guix operating system using Docker daemon. And it can work in some cases, but it's still kind of hacky. And if you want a complete development environment, it will be very hard to make this development environment inside this Docker image. It's possible, but it will be very hacky. Another approach is virtual environment. For example, in Python, there's a tool called direnv. You can install packages inside special directory, and after that you can update your shell with all necessary environment variables. For example, update Python path and path to use this directory, and you will be using Python and all other packages installed in this directory. And it's a good approach, but it will work only for one language, for Python, or for the another language with similar tool, but it works, but for only one language. And also, if two different projects using very expensive dependency, very big dependency, you will be downloading this dependency few times in different directories for each project. It's small downside, but also a downside. But most obvious downside, it works only for one language and for dependencies related to this language. For example, you can't install GCC or other system dependency which your project may use or not. That is why it's easy solution, but not works in every situation. Doesn't work.
Oh, a question.
Yep.
Could we jump back to the frozen images for a sec? So if I've got a frozen image of some dev environment and I would like to enhance it with my DevTools, could I build a new image?
You can, but you have two options. You can maintain your fork of the frozen development environment image and install your tools in addition to this frozen image, and every time original development image will be updated, you also need to update your fork of this image with reinstalling all those tools to this image.
That doesn't sound too good. Bumping each time.
It sounds like maintaining a fork of open source project. It's possible, but you will need to rebase on master of original project, or you need to go in separate direction and your project won't be related to original project anymore, and it will be different branch of development.
So what was the second option?
To lose reproducibility and go in your way and make your own company and use your own dev image with all the tools installed in it.
Okay, not too bright.
Yep.
That feature isn't too bright. Okay, could you show us how to, solve these dark problems?
Part of them. Let's go to operating systems, and here we will start small demos and we'll be demonstrating some ideas how we can improve our development setup. First of all, let's talk about operating systems in general, and most important part of operating system is FHS, which stands for File System Hierarchy Standard. It's a standard declaring how your file system in Linux should look like. Actually, in some other operating systems, it can be similar in BSD or Darwin or any other, but it's not guaranteed. This standard makes different Linux distributions looks the same in terms of file system hierarchy, and its starting point of any Linux distribution. After that, you have some kernel drivers and init RD images, which will help to boot your system and to interact with your hardware. After that, you have init system, which actually starts system and helps to long-living processes to live and work. You have package manager, which modifies your file system, which plays binary of packages in your file system hierarchy. And you have a shell where the most of the work is done, when where you can build something or do some development. And you have graphical environment, which can vary from setup to setup for other developers, and not very important for to be reproducible. It can be different for different developers, and it's not very important. I just reading comments from YouTube about my accent, and that it is clearly understandable anyway. Okay, the good thing about this way of operating system, it's pretty simple, and package manager is just basically a script which takes archive, uncompress this archive, and placing all the stuff inside our file system. And it works, but for example, if you have a package which is a little broken, for example, someone placed another space in the script, and instead of removing previous version of this package, it removes the whole slash or slash user directory and breaks the whole system. You understand that maybe something wrong with those system. Another thing that you understand, you have two similar distributions, for example, Ubuntu like 20.04 and two developers using the same distribution, and they install the same packages but in a different point of time, and they can get different packages because from time to time developers of distribution update their repositories, and depending on in which point of time you executed install command, you can get a different package. And if you broke something, you have a hard time restoring your operating system or reinstalling it from the ground up. It's you want to say something?
No, just emphasize this whole situation. Yes, I feel it.
Yeah, and it mostly because your package manager directly modifies your file system, root file system, and installs all the packages in all those. Oops. Ouch. Let's go back to the slide. And installs all the files in all those directories. But we can go in a different way. For example, we can prepare our binaries, and after we placed them in a separate directory, we can just symlink our current operating system, parts of our current file system hierarchy to those files, to those packages. Moreover, we can create a separate package for our operating system, which will have links to other packages, and when we are ready to switch to new version of operating system, we just change the symlink to from our current operating system to new operating system. And it's actually already possible in some distributions, some advanced distributions like Guix or Nix, but it will require from us some understanding of what's going on.
Man, that's very nice.
Yep.
You'll have the operating system as a value, this giant value.
Yep, we have this operating system, and we will tinker with it a little.
Please, show it.
Let's go to it. Generic GNU Linux operating system is easy, but not very good in terms of reproducibility and in terms of security and reliability. That is why we will go to more advanced GNU Linux distribution called NixOS, and we'll practice some building of new operating system from the ground up. Let's take a file called configuration Guix. It contains one expression which returns a hash map which contains the whole definition of operating system. For example, here you can see that I have a bootloader called grub, and it has some properties. It installed in dev SDA disk. It has some resolution here. I have some extra models installed, and also if I will take a look at hardware configuration. 1 second, I will increase the font size. We will see which kernel models will be installed in our operating system, which parts of our hard drive will be mounted to different parts of our disk. For example, if I will say mount, I will see that our boot file system here mounted using this device, and so on. Just a declarative configuration of the whole operating system. For example, list of the packages, some environment variables, which programs you want to be run, for example, your Pulse Audio or GNU-PG agent, some other file system mounted, definition of your users and groups, your layout, everything related to your operating system can be described in this file. But what I really want in the future from this file to be as hardware specific as it possible, and to contain as little details about the user as possible. And later I will say why I want it to be this way, but let's try to build an operating system from this configuration file. To do it, we need to go to directory where I have those configuration files, and I have a make file which contains pretty simple instruction which says build operating system using this configuration file. Yep, and place what you build in the directory, in some directory on my hard drive, and make a link to it using this name. And let's build it. It will take some time, but not too much, because I already built the system and parts of it already cached. And to make it different from my current operating system, let's check what hostname it says. It says it's Xenia, and I will change Xenia hostname to Xenia Mania, for example. And let's build it one more time. Oops, it says that it's all okay. We can remove this link. Build one more time with updated hostname. And as you saw from previous launch of the comment, it's returned a path. Actually, it's created a link which is linked to this path. We can go to this directory, or we can go to xenia.out, and when I type pwd, it says that we here. But if I go directly to this directory, we will get the same result. We have all the same files. And actually, this folder contains the image of the whole operating system. And this operating system contains configuration files in etc directory, but actually it's not, they are not directly here. It's all those files are links to the other packages. Oops, I wanted to do it a little bit different, like that. And you can see that all those configs is actually symlinks to other files, which is actually files which placed in some separate packages in Nix store directory. That means that our operating system is not actually a list of files, but a list of files, list of links to actual files. That means that if we rebuild only part of operating system, for example, we change only host name, we won't rebuild the whole operating system. We will rebuild the package related to the host name. And if you look at our hostname file, we will see the content updated. But if we type hostname again, we will see that this hostname not updated. It's because I'm not switched my current operating system to the new one. But I can do it. I will do it in a few seconds. For now, we will remember that hostname actually a link to this file, and it's already actual and real file, not a symlink to some other place.
Okay, hold on. So you're going to hot swap the operating system with one command.
Yep.
And zero downtime. Same terminal session.
Yep.
Okay, show it. Prove it. Can't be done. Can't.
Okay. We go back to our directory with configuration files. And here in makefile, I placed a simple target which just runs this command, which switch our operating system to the new one.
Okay, one line.
Voila. And let's take a look at our hostname. Boom, it's updated. And
Shit.
Currently, it's a real new hostname. And we did it in one command. And now we will just remove the link. We can update our hostname again. And let's build, okay, make, boom. Let's build this target one more time, and let's check that now it will point to a different hostname file. Do we remember original name of hostname file? This one.
Just Xenia?
I will
okay.
place it here. Actually, it's still presented. This file is still presented, but our new build, new image of operating system now located here. We go to this directory and let's do this command, and it will point to different file, not this one.
Why? Why?
Because we updated our hostname, it created new package for hostname and updated the link for the hostname file to new package. And
but okay. So first we had the config which stated Xenia as a hostname, right? Then we changed it to a different value, and the new image of the operating system got generated, right? And then we switched the hostname back to Xenia, the original one. Do we have 3 different images at the end, or just 2?
we have two different images.
Ha, sweet. Why is that?
Because when you're updating something, the name of the package consists of the actual name of the package and some hash value. And this hash value based on the inputs for this package and actually the package. And that is why if the content and input of some package are still the same, the value of this hash will be the same.
Nice. Operating system as a value.
Like that. Let's go back to our directory and make deploy. Let's switch to our original operating system and let's go back to our slides. The advantage of such advanced GNU Linux distributions that they are very simple. Idea is pretty straightforward. You have a whole operating system placed in one separate directory and you change the link to this operating system in some place in your file system hierarchy. It gives you a very good benefit in terms of reliability. When you break your system, you install the wrong kernel, wrong drivers, or wrong programs which breaks your X server or Wayland session, and you want to go back to previous version of your operating system, you just switch the link to the previous image of your operating system and you are done. Pretty cool, I think. And also...
Can I stop you for a second? Can we apply this technique to promote stuff to production, to dev, to different environments?
Yeah, actually, we even can build all those packages locally and just ship them already built to environment. We can build the whole operating system and just deploy this operating system to the production. And it will be very efficient because you will copy only the part which was actually modified. But all the same packages that was already built and not changed will still the same, and you won't copy them, and that is why it will be pretty efficient.
That's nice. You can actually run the stuff locally and then ship to dev and be sure that it will work the same.
Yeah, it will be absolutely the same binaries that you built locally, and you can ship them directly to the server, or you can send them to some cache server, and your dev or production environment will pull them. It depends on your cluster setup and how you want to manage it.
Okay, that's cool.
Yeah,
thank you. Let's go ahead.
The only downside that it's not usual for people to think about operating systems in this way. It's like immutable data structures. People don't understand why they need to use those strange data structures when they can use just simple arrays, which is perfectly aligned with the computer memory and works in a very intuitive and obvious way. But you know, functional programming becomes more popular, immutable structures, data structures becomes more popular, and the same trend will be, I think, will be in operating system, that they become more functional, like in functional programming, not like in a number of functions. Okay, it's a little harder, it requires better understanding, it's not so familiar, but yep, it's very...
I'm not sure if that is harder.
It's not usual. Maybe it's not harder, but it's not usual for people, and that is why they can think that they are harder for them.
Gotcha, right.
Two links to two operating systems which are doing similar things in terms of managing packages and operating system itself in the way I showed here. And let's talk about package management. Actually, we already talked about it a little. Let's talk about it a little more. how we install what difference between project-related tools and project dependencies. In most cases, we separate those things because project-related tools doesn't contribute in the final project. You don't ship your building system with your product in most cases. You don't ship your cluster management tool with your project also. That is why we separate them. And dependencies is something that your end product depends on. For example, libraries or some other sub repositories or something like that. And it will be everything related to dependencies. And we are talking about package managers right now, and we have OS-specific package manager. For example, for Ubuntu or Debian, it will be apt. For Red Hat based distributions, it will be RPM, and for NixOS it will be Nix. And we talked about difference of those package managers already a little. First, more usual package managers just have an archive with all configurations and binaries and all that stuff built on some server by maintainers of this distribution, and they have a script which says how to copy those binaries to your file system, and it directly modifies your whole operating system. But in more advanced package managers, all files will be placed in separate directories, and when you are decide that you want to use those packages, you can switch some links, and those packages will appear in your system environment. Also, you can even just place them in this separate directory and use them by setting only path variable in your shell. That means, first of all, you can have few different versions of the same package. For example, you have Python 2 and Python 3. Both provides Python command, but if you install them in the same directory, they will kill each other because they use the same package, the same file name. But if you install them in separate directories in one shell, you can say that you want to use Python 2 from this directory, and in another shell for another project, you can use the Python 3 installed in a different directory, which I think very useful sometimes, and very
That's
smart.
really useful, yes. Yes. I cannot rely on the Ansible script because it will go and break my tools. It will install on top of my Python 2, Python 3. And when I'm done using the tool, when I'm done playing with it, with a repo I just downloaded, Python will be still there.
Yep.
I mean, Python will mutate permanently my system, and I may not ever recover it. That sucks.
A little, yeah.
Yep. Isolation, please.
Another package manager that many developers uses is language-specific package managers. For example, npm, maven, or something like that, or pip for Python. They are better than system-wide package managers which actually modifies your system, because they can install your packages in a separate directory for a separate project using tools like virtualenv for Python and so on, or using just a separate directory which placed near your project, like node modules in your JavaScript project. And it's a good idea, but not so good, because downsides we already mentioned, but it can work for you. The reproducibility, the problem of reproducibility will be here if you can't guarantee that you will install the exact version of this dependency. And another problem of reproducibility, for example, your Python project, which communicates with CUDA, requires some system-wide dependency, for example, NVIDIA driver, and you can't install NVIDIA driver using your language-specific package manager. That is another downside of language-specific package managers. There are many different type of package managers. Some of them are good, some of them not so good. But the problem is that you can't manage your system dependencies using those package managers, because they know only about one ecosystem, your language ecosystem. But if you have 2 languages or more, you won't be able to manage them using one package manager. Yep, and we have language agnostic and system agnostic package managers. Actually, Nix is not only an operating system. Actually, NixOS is operating system, and Nix is a package manager, which can be installed in different operating systems, even on Macintosh operating system. And you can use it without using NixOS operating system at all. And it's an example of language and operating system agnostic package manager. You can install system dependencies like GCC, libc, Python, kubectl, and all other stuff that you want and need. But you also can install packages like pandas for your Python dependencies using this package manager. And it's also very neat, as we already saw with all those examples with Symlinux. Yep. And
so I could use that package manager on top of my operating system.
Yeah.
So I'm running Ubuntu and I can use it. Nice.
Yep, sure. About project configurations and environment variables. In most cases, it's enough to just place all the configurations in one place in some file, which contains all environment variables related to this project. And when you start working on this project, to create a shell which will source all those environments variables and all other configurations in your shell. It can be done using some tools like direnv, which helps to automate this process. When you go to the some folder, it will automatically source all the environment variables from env.rc file, and you will be set up and ready for working on this project just by going to the directory of this project. And here you can see, it found few pandas packages in the repository, and actually it found different packages for different Python versions. If you go back to my home directory, you can see that direnv said unloading, and when I go back to configs directory, you can see that it loads env.rc. And actually in env.rc I could write all the environment variables, but I wrote here lorry direnv, which means that it will look at shell.nix file and will look for all the packages that I need for this project, and will make those packages available for me here. And let's take a little deeper how it works. If we here in our home directory, and we take our path variable and split it by colon, we will see all the directories in my path variable, and let's assume that all those directories are system related. But when I go to configs directory and execute this command again, you will see that much more directories with binaries appeared here, and you can see that GCC appeared here, GNU make, and all other stuff, stow, which is declared in shell.nix file, appeared here. And also I can do something like shell.nix minus pure, which will bring me to the environment where I will see only dependencies that installed using this shell.nix file without any system dependencies. If I want to be sure that I don't use any system-wide dependencies like system version of Python, for example, here in my system I have Python 2 installed, but here in my configs I don't have any Python installed. But if I will go to my project which uses Docker Compose and will type Python here, I will have Python 3 here. And in one operating system I have 3 different shells with 3 different versions of Python.
Nice.
Yep.
That's cool. So inside of the Nix image, Nix operating system, which has this nice property of isolation itself, you can have differently isolated environments.
Yep. Actually, you can have those isolated environments using different tools. For example, Python virtual envs work the same way, but they work only for Python packages, which will be installed in the separate directory. But here, Nix can manage not only Python packages, but all system packages and packages of other language. And that is really cool that it uses Nix language, which is very extensible, and you can use it for building a project which contains few different languages at once, and you will be able to do it relatively easily. At least it's possible. Maybe not easy, but possible. In world of package managers, where all the packages should be provided from some repository, it will be much harder to do such thing.
Okay. Could we just go and see how difficult it is in my setup to do exactly the same? To get the Nix going and to get inside of your project and see this Python 3.
Actually, I have a slide about sample setup. You need to install Nix on your system, and if you don't have Git, you can create a shell which will contain a package Git using this command, and after that you clone a repository of my project and go inside.
That's it. Okay, let's take a look.
Can you share your screen?
In a moment. Wait for it. Can you see my screen?
Yep, I see it.
Nice. Beautiful recursion, and let's go and check it out. Don't need to upload it there. I have the Nix shell cloned already. Let's see Nix shell. Can we check it somehow like version?
Yep, probably.
Sweet. And we've got the TWTF project here.
Can you type make?
Make. A simple make? Okay.
Yeah. Oh, it works. Okay. Can you type Docker Compose up?
Docker Compose up. Nope, I don't have it.
Yep. And type make space db/start. Slash.
Oh.
db/. Yep.
The command not found. Oh, darn shame. I wouldn't like to put Docker Compose in my global tools.
Yeah,
that's a big blood of stuff.
But you have shell.nix file. Can you check the content of this file?
Shell.nix.
Yep. And
we've got
as you can see, it installs Docker Compose, GTK, PostgreSQL, Git, curl, GNU-make, Clojure, and GCC. And now you can just type nix-shell.
And
Yeah,
that's all?
That's all. Yeah.
That is
And
simple.
you get the shell where you can type make db/start. And it will run Docker Compose, but it will break.
I do have Docker Compose, yeah. Huh.
File not found. Okay, anyway, you at least have Docker Compose. Now there are another problem.
Docker Compose version. It's surely there. Sweet.
Yep.
And if I exit and try that in my global environment, there. Nice. Missing. Okay, I'm happy. I do like that.
And actually, Docker is system-related dependency, which you probably can't install from user space, and that is why it's if you have some system-related dependencies like CUDA, which uses NVIDIA drivers and which uses some special models for the kernel or something like that, it's better to have operating system managed like NixOS using declarative approach, when you can share the part of this configuration file, and to reproduce this part of operating system on your machine. But now we will be talking about services and about Docker and systemd, and we will cover your case when you have all project related tools installed, but you can't run the Docker. Okay, in most cases in your project you need some kind of long living process like database or queue or cache, and you can do a simple thing. You install this project related tool like PostgreSQL and run it just from command line using your terminal, and keep it live and running for a long time until you finish with your development, and it will work. It's a way, but you have a different way. You can use OS specific service manager, for example systemd for NixOS or init 5 for Gentoo or other operating system. But the cool thing about OS specific tools that they can run services in user space. But we will talk about it later. In general, when you depend on some OS specific, it makes your setup less reproducible, and you can't rely on that. For example, if you have developers who uses Linux and developers who using Macintosh, you can't be sure that both people can set up this service in the same way, because macOS don't use systemd or other Linux distribution don't use systemd. That is why it's not very reproducible way, but we will look at how it can become more reproducible. And here we have a Docker, which is actually also not very reproducible. Because it's hard to install Docker on some operating systems, because you need to launch a virtual machine on Macintosh to launch the Docker image inside it and so on. It's possible, doable, but you know, you can't write the one instruction which will describe how to install Docker on any operating system that your developers can use. That is why it's better to stick with GNU Linux operating system for all developers of your team. But in some cases we have to use Docker, and Docker not a bad tool, but it's a hack which appeared due to problems of our operating systems and our package managers, which was not reproducible at all, and we decided to freeze the state of our operating system and distribute the state using those Docker images. Docker images itself very reproducible because it's really a snapshot of the whole operating system, but Docker files, which is instruction for building a Docker image, not very reproducible because it's very dependent on the environment where you run interpretation of this Docker file. Overall, if you use this tool, Docker tool, and your cluster set up using Kubernetes or Docker Swarm or something like that, you're good to go with it and to live with it. It's probably work and will be very reproducible. And even better, maybe you can build Docker images from Nix expressions. For example, you define all the dependencies of your projects inside Nix expression, and after that you ask Nix to build a Docker image from this Nix expression, and this build approach of Docker images will be very reproducible in comparison to Docker file. Overall, good tool. If you use it, continue to use it, but be careful. Docker files not reproducible if you run them in different environments. And OS specific services version 2. If everyone in your team uses the same operating system or similar operating system with systemd, for example, and they have a package manager which is very reproducible, and they have a declarative configuration of operating system, you can define a configuration of your development environment which will contain user space services, which will, for example, instantiate Postgres database in your user space, and you will be managing it using systemctl, which is a tool for managing systemd daemons. And you can even isolate this service from other services using cgroups mechanism. And I think someone will make a tool which will be similar to Docker Compose, where you can describe all the necessary services that you want to run and all the packages that require to run those services, and you will be able to easily run the all services necessary for your project in one command and shut down them, and to be sure that they are isolated and don't conflict with services in your operating system or services of other development project you have.
So there can be potentially like 1,000 microservices, and you can run them in isolation on the same hardware.
Yeah, actually you can even make a separate networks for one project, and you can run few different services on the same port for different projects, and they will work, but you will be able to reach them only from the one cgroup and not be able to interact between them because they will be isolated. I think it's some kind of nearest future, and this tool will appear pretty soon, maybe.
Oh man,
I'm doing so much predictions during this stream.
Well, let's see how close you are.
Yeah, but
damn it.
But we'll see. We'll see.
I do like this isolation so much. Well, it will be a struggle to do the same with Docker images, right? 1,000 images on the same machine.
Actually, it's probably possible to do such kind of isolation. For example, if you don't expose a port for a Docker image, you can run many Docker images, and all the services inside those Docker images can use the same port 80, for example, and you have 20 web services that using port 20, 80 inside their containers, but don't expose this port to your host machine, and you will be good.
Okay. So Docker seems like a strong competitive. It does something very similar, right?
It's strong competitor because it's very popular and many people already familiar with it. But I think in the future we it will be good to move to more more interesting approach, like based on all those reproducible stuff from Nix and NixOS related distributions. It's not necessary to be Nix or NixOS, it may be Guix or maybe any other distribution with nice package manager and nice approach to manage your system services. But you know, Docker won't disappear. It's a good tool which works for now, but I think that future should be a little different. Maybe I'm wrong, but it's my own humble opinion.
Well, to add one more humble opinion, less expert one though. I don't like that it's a bunch of values. That's Nix is just a bunch of values, and you compose those values into the operating system. You've got a bunch of software dependencies which are just values, and you compose them together. Here's your OS image. Do whatever you want with.
Yep.
And just beauty and simplicity.
It's very, very nice ideas from the world of functional programming. And you probably feel that it's very close to your experience with functional programming.
Yes, I like that part much.
It may be some kind of bias that you're not very objective about reasoning about this operating system because you already have a background in functional programming.
Ah, yes, spoiled. Right, yeah, please carry on. Thanks.
Yep, let's go to the almost last part of our talk today. We're already talking for more than an hour. It's a long talk. User space apps. Your browser, your IDE. I'm already tired a little. And all other stuff that has some configurations. Your Git or other tools that you use for development should be configured somehow. For example, in your browser you can click here, more tools, plugins, developers tools, or settings, or something else, and modify the behavior of your browser to disable corners for your tabs or something like that, to install new plugins. You can do it. But when you move to another workstation, you have to do it one more time. Every time you're moving to new operating system, to new hard drive, to new hardware, you need to redo it. But actually it will be cool to keep this state in some configuration file. Actually it's for browser it kept somewhere in configuration file or database like SQLite database. For your text editor like Vim or Emacs, it stored in configuration file or your init script for this text editor or IDE, and you can copy those configuration files and you will get the same setup in new machine. And many developers storing those dot files, they call dot files because they have a dot at the beginning of the name. If we take a look at my home directory, you will see a lot of files with dot prefix. For example, configuration for my shell or configuration for Tmux and all other configs. They just store them in a Git repository, copy this Git repository and symlink to these files in this repository from your home, like here. And there's a tool called Stow which helps with the symlinking, and you can find this tab of those dot files in the repository. It's my dot files. You can check what I am currently using here. You can see how my setup looks here in README, and you also can find some old dot files that I used some time ago here. Yep, it's easy, pretty obvious way to manage configuration of your user space applications, but you can specify in those configurations which system-wide packages you want to use, and that is why you need to install those packages using your package manager, and you need to write here in README that before doing all of that you need to install this package and this package, and after that you copy those dot files to your home directory and they will work. And as you can see here, I didn't wrote that, and maybe some of those configurations won't work for you because you don't have some system dependencies installed, system packages. I say system packages, but they can be installed in user space, as I showed this example here when we run Nix shell, which contains a different version of Python for different project. But it doesn't matter. The important point that we can specify dependencies. And not all applications supports text configurations. That is why we can't, for example, store configuration of my Chrome browser and all extensions that I want to use in my Chromium browser in configuration file. But luckily we have a special go back please. Special, let's call them dot managers. It's something that allow you to describe your whole configuration of your user space applications in declarative approach, like I defined my operating system, the same way I define which programs I want to see in user space and which configurations they have to have. And I even can specify which Chromium extensions I will be using. And after I declared this big and interesting declarative configuration, I can say, hey bro, can you build me a package which contains all the necessary dependencies and all the necessary configurations? And after that I can place a link not to my Git repository, but to some file in Nix store blah 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 zshrc file, and now it will look like that. And when I want to update some configuration, I just update my original configuration file and just rebuild it and update those links. Actually, those links will be updated automatically by this dot manager, and I don't need to care about manual updating of those links. It will work the same as it works for the whole operating system I use. Yep, and it is another approach, and the downsides similar to using advanced GNU Linux distributions. It's a little bit harder and requires a little bit more understanding, but it's much more reproducible. You can just copy a configuration of your home directory and all your user space programs and replicate them on any other machine just in one command. And these tools in most cases very extensible, and you can describe configurations and the way those configurations will be generated for different programs, not for the programs which already exist, but for many other programs that you really want to configure this way.
Huh. Can I? So is it like a semantical layer where you can define what you want to have in any .config in your system? It's like configuration of your home layer, just in data.
Yeah, it's like a configuration of your home directory. You can even say that you want those movies from torrents to be downloaded in your video directory if you want. It's very possible. And you want to be sure that this actual movie will have the hash equal to that hash, to be sure that it is exact the movie that you wanted to download. Yep, it's possible.
Okay. And can I extend this configuration with any?
Yeah.
So if I say it has some pre-built parameters you can specify, for example, Chromium plugins. You can enable some Chromium plugins. What if I want to go inside of a Chromium plugin, let's say Chromium Vim, and I want to change some settings, like put HJQL to something else, to VASD? Can I do that?
Probably you will need to understand how the settings stored inside Chromium, and to make some wrapper which will make it possible to generate this configuration for Chromium from the definition you provide to it. But it's possible theoretically, but I don't know how hard it will be in practice.
Nice. And it's possible to plug in different realization, like plug in some open source extension for that config, right?
Yeah.
Nice. So
actually, you can just look at some people's configurations and see how they implement such things like Chromium configurations. They already have Nix expressions written for that. And you can just take those expressions and copy them or include it in a different way, for example, using flakes, which we will be talking in a few seconds.
Gotcha. It will merge their config to mine, right?
It depends on how you implement it and how they implement it. Maybe it won't be possible to reuse their config directly by referencing it, and maybe you will just copy paste part of it.
Okay. And to be clear, there's a question: is it possible to plug in different people's implementation of like how this config is being interpreted? So some guy wanted to configure a Chromium plugin, and he wrote some implementation on how it's done, and he exports some parameters to the configuration. Is it possible to like plug in that implementation? Is it possible to like compose?
It depends on how he implemented it. The simple question, yes, it's possible. The more extensive answer that it may be not so easy, or it may be not possible because he implemented it in a poor way where you can't reuse it. But in general, if person cared about that someone will be reusing those settings, he could implement it in a way where you can just put the link to his repository and say that you want to use this and this setting from this repository.
Okay, so it's that. Okay, thank you.
Here's a sample setup that Andrew already did on his machine. If you want to try it.
Make shell and db start.
But here you need to have a Docker installed. It's a system-wide dependency that I can't use, that I can't install without access to your operating system. And the way I described user space services, it can solve this problem of the Docker. that you have to install it in the system. Those system user space services maybe won't require any additional installation to run a database inside your development environment. And it will remove the last part of not very reproducible development setups, and we will be pretty good with our developer setups in the future. Yep, and about the future, nearest future, I called it distributed immutable dependency system, but I just wanted to make some nice acronym, nice and funny acronym like DITS, which is similar to some other words. Let's imagine that you put the file, for example, containing Nix expression, which says how I can use this repository and which inputs it requires and which outputs it provides. For example, I create a repository which contains as input few different Emacs plugins, and as output it contains the configuration of Emacs setup. And I will be able to install it like Nix build GitHub abcdw/emacs config, like that, and it will create a Emacs configuration, and it will build a package with Emacs configuration, which I will be able to use by symlinking it or to use it in my other tool which manages my user space applications configurations. It will be pretty cool, and it will allow to use the existing ecosystem of all Git repositories as our source for packages. You can convert every repository to a package and use it from your command line without any hassle. And also important thing, how to be sure that this package will be reproducible. Each time you specify your dependency, like inputs for your package, the other file will be created, which will be a log file, which contains the exact version with exact hash of this dependency. And in this way you will be able to download this exact package with all exact dependencies of this package and be sure that it will be built in the way the author of this package wanted it to build. The problem is, for example, you depend on the source code which disappeared. For this problem the solution already exists, and it's called software heritage, which contains a lot of source code, open source source code, which stored and archived here, and Nix project copyright with them, as I know, and that's mean even if the original source code of the project of dependency of your package will disappear, you still be able to build it using this software heritage archive, and it will be good even if the original source was deleted or moved or something else happened to it. Yep, and it's a little bit about the future and how our packages can migrate from centralized repositories to distributed system like Git, and can be splitted among all those services that contains all those Git repositories. Yeah, and you can just say that you depend on this package which described in this repository, and you will be sure that this package won't be changed because you depend on exact version of this package. But if you want to update, you have a special tool which updates your log file with newer versions of the packages. Boom. And such tool already exists, and it's called Flakes. It's still in some development stage, but it already worked and you can try it. Here's a blog which describes the basics of this tool. And that's all for today. Any questions?
Oh boy, oh boy. Yeah, some. Well, first of all, yes, that's lots to take on. I think I'll be brewing it a couple of days, maybe weeks. I'm not sure that it will settle in nicely. But yeah, question so far. Could we take a look at the flakes and how could we use the GitHub Git repos as part of our package definition?
Okay. Let's take an example from NixFlakes blog, and let's open github.com/ this guy / this repository. In this repository we have some sorry C file which contains some source code, and we have flake file which contains inputs. For inputs it has only Nix packages, and for outputs it provides default package which actually builds the dwarfs package. And here we can run a Nix shell and specify the exact version of this dwarfs application. And it doesn't exist. This revision doesn't exist. Let's take another revision. 55 commits. Let me take the last commit. Yep, this one. I will take it and we'll place it here. Boom. Oh, now it's downloading source code, and also downloading dependencies for this project. And now I am in a shell where I can do something for building this dwarfs application.
Oh man.
Oh man. For example, I can type nix build and it will. Oh, I need to okay, I need to provide this role. Now I am in a shell which contains all the dependencies which necessary for building this dwarfs application, and let me check that it is true. I will take a look at flake.nix and we'll check build inputs, fuse, nix, boost, and it seems that's all. Ecopass. Oh, yep, we can see that. Oh, here we have dwarfs available, already built. Okay, I can type dwarfs -version and it will say something. And in my clean shell, if I type this command, it will say command not found. I didn't install actual package in my system, but I created a shell which contains the executable.
Shit.
From this repository. Yeah.
Well, that is very nice. That's next level of utility. You can just give git sha and you'll have the exact development environment needed for that project.
Yep. Actually, you will have already built a project here if you type nix shell. And using, for example, list inputs command, it will show on which packages, it depends. Here it depends only on Nix packages itself. And we can see what outputs it can provide. And here we see that it can provide NixOS models, it can provide default package for different architectures, and also it can run some checks, probably for running tests for this package. Yeah, and we can get any of those outputs. For example, we can get checks, Linux test, and we'll get an ability to run all the tests against this software. Yep, and I think it's kind of futuristic, and it's kind of feeling like a future, that you have ability to interact with different repositories like they are packaged, and you can get some outputs of those packages, and it's pretty cool. For example, I can create another repository, and this repository will be depending on this flake, and we'll be using, for example, this output as input, and in this way you can build a network of packages that depends on each other in this big ecosystem of Git repositories. Mind-blowing, probably.
Yeah, that's a bit. That's not a light burden to take on.
Okay, I think that we already talking for hour and a half. Quite a long talk, but it was an interesting talk. At least I hope so.
I think that's. I think that's where we should focus as software developers our attention. We have a bunch of legacy abstractions, legacy architectures, and it's just too much. At this stage, it's too much. We have React Native, and it's too big tower of abstractions, too much stuff that could be done differently. And the technique that guys at NixOS, at Nix, introduced to us, it will simplify a bunch of things. It allows for like a sea of possibilities which we just cannot do currently. And I hope that this will be developed further.
Yep, it for sure will be, and maybe we will be part of it. Okay, let's contribute to Nix and NixOS.
They should be some hardcore guys. I don't know. That'll be my level. What I do want to do is I like to install NixOS, and I think I've got just machine here.
You got enough inspiration to use it and try it?
Yes, I'd love to install it, and I'd love to poke around.
Good. I'm glad to hear it.
Maybe we could do it live.
Yep, you can. Why not? Maybe we'll stream how we do it. It's a good idea.
Okay, let's think about it, and yeah, tell us if you would like to see that, guys.
Yep. Thank you everyone for participating in this very long, but I hope interesting and maybe futuristic talk. And we will see you next time. Bye.
Good much. See ya.